Go. In 3.6, we're going to learn the last of the 5 shortcuts. In 3.2 and 3.3, you learned 4 shortcuts that prove triangles congruent. This is your 5th one. I told you that there were 5, and so this will bring you up to knowing all of them. The shortcut's name is HL, and all you really have to have is a hypotenuse and a leg of one triangle congruent to a hypotenuse and a leg of another triangle. If that's true, then the 2 triangles are congruent by HL. I have a picture here because I know most of you know what a hypotenuse is, but you can't have a hypotenuse unless you have a right angle. So the only issue that people have with this particular shortcut is that it looks like something else. It looks like a side and an angle. Let me show you the picture. If I look at these 2 triangles right here, and you're using any method that I taught you in 3.2 and 3.3, you might look at this and say, I have a side, I have a side touching another side, touching an angle. I have a side-side angle that's a side-side angle. Well, there is no side-side angle postulate. It doesn't exist. But is there a hypotenuse and is there a leg that's the same as a hypotenuse and a leg in the other triangle? And if so, you do not write SSA, you write HL. The easiest way I remember that is I'm a teacher, and you're not allowed to write certain words in school. So if you see this and you go, can I write that down? You're going to say, no, it's not allowed. And mathematically, it's not allowed as well to write down anything that would be a bad abbreviation. Do you see it? I'm sure you do. I just don't want to say it because, I am putting this out there on the internet for any parent to hear. Oh, Parable, you're going crazy now. I got to keep my job. Okay? So no side-side angles around here. Don't call each other side-side angles because since you're all intelligent, you'll know that you're trying to be funny. That's mean. We don't want to be mean. Okay? So if you see this, you need to look to see if it has a right angle. If it does, then it might be HL. If you see a side-side angle and there is no right angle, it's not enough information. Okay? I have seen triangles that look like this, and I've seen a triangle that looks like this. I'm sorry. This is the one I wanted. I need to erase that guy. Let me erase. There we go. Side angle and side angle. This angle is the same as this angle, and this side is the same as this one, and you have a side angle. And then people say, they're congruent to each other by side angle. Well, side angle doesn't exist unless there's a right angle. Then you can use HL. Okay, just so you know, these are not congruent to each other, and there is no such thing as a side angle proving that they're congruent. This is always not enough information, just in case you see something like that. The last thing that we're going to need that we wrote down is that there's a difference between knowing something is perpendicular and knowing it's a right angle. So a lot of times in proofs, we will have to say, we know that they're right angles because they are perpendicular. I know this is a right angle because of the definition of the word perpendicular. So we're going to use that fact when we're dealing with these problems. Which brings us to our examples. I have 3 picked out for you, and I do not do them in order for whatever reason. I decided to start off with the easiest one first, which is number 6, and then we'll work our way up to the harder, the medium, and then the hardest level. Number 6, in your book, you can do this in your book if you would like. It says, determine whether the 2 triangles are congruent. I look at number 6. I have this as a right angle, but it doesn't have over here anything. I'm hoping you know about vertical angles, that the vertical angles are always congruent. If the vertical angles are always congruent, then what does that mean that angle LMP, what does this angle have to be? You can do that because of vertical angles. Are the two triangles congruent, yes or no?
Yes.
We know that they are congruent. It doesn't ask us for this, but I'm going to write because of HL. Because this has a hypotenuse, that has a hypotenuse, and a leg that's the same. If so, write the congruence statement. That is where we write one triangle is congruent to another triangle, and the letters have to match. Usually, for me, because this has a 1 and this has a 2, I usually go 1, 2, and then end, and I go MLP. That's how I kind of pick my letters. I don't usually just pick alphabetical order. I kind of usually use what has 1 dash and 2 dash, so that way I can go 1 dash and 2 dash and the other one, and then it usually is pretty simple to follow. That will make sure that my angles and sides are corresponding, otherwise known as matched up. This is part of our answer. Yes. Here's the congruence statement. That's the easy one. Harder one, number 3. Number 3 is a proof. Number 3 asks you to prove that the two triangles are congruent to each other. And it has all this stuff for the given. We got to come up with the reason, and it doesn't even have how many spaces you're supposed to have. I have 4 up here because it's going to be 4 statements and 4 reasons. The first statement, by now we should know, we just take whatever's given and we can write it out. If you are particular, you could have this as your first statement and this as your second and this as your third, but if you do that, you're going to need 7 lines. I'm not going to do 7 lines. I'm just going to put everything and squeeze it all into one. I write all that stuff, squeeze it into my first statement, and what is my reason? If you know it, say it out loud. Good job. Now your textbook starts throwing things in your picture. Don't expect anything to be in your pictures on any quiz or test. If it's there, yay, you got lucky. But most of the time, you're going to have to take your information and add it to your picture. GH is congruent to TV. You got to make sure that that is added to your picture. Notice they added these right angle symbols, but they haven't done anything. All they've given you is that HV is perpendicular to GT. They haven't said that GIH is a right angle. They have not said that angle VIT is a right angle. But they have proven that they're perpendicular. That's given to you. So you need to make an extra statement. You need to be able to tell me that they are right angles, and that has to be its own separate statement. You have to be able to tell me angle, GIH, or HIG, same one, and angle, VIT, or angle TIV, same thing, are right angles. It didn't say that. It only said that they were perpendicular. So we're going to make a statement that now tells you that this triangle has a right angle in it. Sophia.
Can you rate it as like 90 degrees?
Are equal to 90 degrees. I've read a lot of proofs and different geometry authors. They will write those as 2 separate statements. You have to say, oh, this is a right angle. Oh, now they're equal to 90 degrees. Like that is usually considered a separate idea. Why do I know that these are right angles? Because of the definition of a word that we have up in our given statement. And what word am I using? I'm using the definition of this word, which is perpendicular. Do I have to write out the word perpendicular? No. You can use the symbol. Definition of perpendicular. Now the last thing that I see up here that they gave me I is the midpoint of HV. Midpoint between here and here. If it's the midpoint, then I know that two pieces have to be congruent to each other. Which two pieces have to be congruent to each other? Segment HI and segment IV are congruent to each other. What lets me know that? What definition am I using?
Midpoint.
Right, so we're going to write the definition of a midpoint lets me know that. And then I can add that to my picture. I've been grading this weekend. I was grading some regular Math 2 students. And sometimes they would add something to the picture and they wouldn't have that statement in the proof. And I'm like, we should know anytime we add something to the picture, we need to have a statement and a reason why we're able to do that. Don't ever put something in your picture that you haven't stated or have a reason for. Which brings us to what we're trying to prove. We're trying to prove that triangle IGH is congruent to triangle ITV. IGH, ITV. I know that these two things are congruent to each other because I have this leg is congruent to this leg, and this hypotenuse is congruent to that hypotenuse. What postulate or theorem could I use that proves them congruent? Say it out loud.
HL.
So close. For HL is correct. It's okay. The last example I have for you is number 13. And the reason why I have number 13 highlighted for you is because it involves something that you probably haven't done since last year, called systems of equations. It says on number 13, for what values of x and y are the triangles congruent by HL? Well, which one is the hypotenuse? Hypotenuse, hypotenuse. Which one is the leg? Leg, leg. If these are congruent by HL, then the hypotenuse is, I don't even know if that's the right word, the hypotenuse, whatever that is, that's a crazy word. Both of them are equal to each other. So there's my first equation. The 3y plus x should be equal to y plus 5. And my second equation would be the y minus x should be equal to the x plus 5. You have to have two equations if you have two variables. That's the one that I go, oh man, they're going to forget, they forgot about this. That's my guess. But these are quite fun. So what I can do now is take this first equation and I can subtract a y from it just to simplify it a little bit. 2y plus x is equal to 5. That makes it just a little bit smaller. That's equation number 1. Equation number 2. I'm going to subtract an x. X minus x is 0. Negative x and negative x is negative 2x. And so now what we have is we have equation 1 and equation 2. They're both equal to 5. And so we have a couple different choices. How do we solve for this? You can either use the substitution method, or you could use the addition, otherwise known as the elimination method. I would not solve by graphing unless you had Desmos. That's the third possible way you could do it. So what I'm going to do is I'm going to use the elimination method since, well, okay, I'm curious. How many of you would do this with the substitution method? Raise your hand. 3 hands, 4 hands, 5 hands are up. How many of you would use the elimination method? Raise your hand. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so more elimination method, people. I'll do it both ways. Why not? Here we go. I'm going to take this. I'm going to line it up over here. But it wouldn't eliminate yet because if I add those together, one of those wouldn't go away. So what I would need to do first is I would need to probably multiply this top equation by the number 2. So that I get, let's do this right over here, 4y plus 2x equals 10. And then this equation would be a y minus 2x equals 5. And what that would allow me to do is that when I add them, the x's just go away. The y's would add to 5y and equals 15, and we could figure out what y is very easily. That's the elimination method. The elimination method finds one variable, and then you plug it back in to find the second variable. 2 times 5 plus x equals 5. 10 plus x equals 5. I did something wrong, didn't I? Oh, come on, Mr. Paramo. Divide by 5. Divide by 5. 15 divided by 5 is 3, Mr. Paramo. 3. 3. Who noticed that? Thank you. Next time, speak up, please. Doesn't matter that there's a recording. I don't care. Correct me if I'm wrong. Let's erase that mode. Then that makes 6. Minus 6. Minus 6. X is equal to negative 1. Got my 2 answers. If you like the addition method, it's good. A lot of times you just have to change one or both equations to get it to work. Those of you who said substitution, you could have easily done 2x plus y, or 2y plus x equals 5. And then this other one has a y minus 2x equals 5. I'm going to put y equals 2x plus 5. I'm going to add the 2x to this side. And now I'm going to substitute that in over there. 2 times 2x plus 5 plus x equals 5. 4x plus 10 plus x equals 5. 5x plus 10 equals 5. 5x equals negative 5. Divide by 5. And x equals negative 1. Same answer. Substitution method. If you do both methods, you should get the same answer, assuming your algebra is correct. And then substitution method, you take your answer, plug it back in to find the other variable. Which brings us to the end of your notes for this section.